This is a recap of the exponential function equation. Pause now to review. I'm going to show you how I would graph this exponential function. First of all, we need to identify the parent function. Parent function is always y equals the base. Now, the base of the exponent here is a 3. Notice that exponent is x, below it is a 3, so 3 raised x. That's my parent function. Now, we always use the same x's because the important thing of the parent function is what happens in the middle. So 0 and a little to the left and a little to the right. Now, this middle column is here for you if you would like to show your work and plug in. We start with 0, plug in a 0 here. So 3 raised 0, 3 raised 1, 3 raised 2, and so on. And that is what your parent function table should look like. And that is what your parent function graph should look like. And I'll even zoom in on that. Now, the question is, how does this parent function differ from the actual graph that I'm being asked to graph? Well, there's a few things I notice. I notice a 2. I notice a -5. So we should identify, well, is that an A, an H, or a K? Well, the 2 is in the A position, and the -5 is in the K position. So we need to remember, what does A and K actually do? Well, A is a vertical stretch or shrink. It could also be a reflection. It's a reflection if it's negative. Now, this is positive, so we're not going to be reflecting, but it is going to be a stretch or shrink. In this case, this A value is above 1, so it's a stretch. What I'm going to see is this graph is going to stretch taller, 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 taller. But it's going to stay where it is, but all these points are going to, in this case, 2, is going to double its height from the ground. So let's see what that looks like. So here I have my parent function, and since A is equal to 2, all of the heights from the ground is going to double. Now, this is such a small height that its doubling is not going to be so significant. I'm going to start on these larger values. So this has a height of 1. When it doubles, it's going to move up to 2. This has a height of 3. Double 3 is going to be 6. So it's going to have a height of 6. And double 9, can you guess? We'll have a height of 18. So let's see, watch what happens as I increase my A just so slightly. Do you see them climbing? Did you see it stretching up? It's not that the whole graph moved up. Notice that these move just slightly, these move more largely. It's the height from the ground. Did you notice the ground did not move? So you can't see that the entire graph moved. Instead, the height stretched by a factor of 2. So this is my new parent function plus all the A stuff going on. If my A value were negative, this is the time where I would then take all these heights and flip them below. So that my graph would then go down. But since my A value in this case is a positive 2, I'm going to keep it as is. So what I've done is I've replaced my graph with my parent function plus any vertical stretch, shrink, and flips. And what I have here, I have done my 2, my A equals 2, so I've checked that off, and we can say that it is a vertical stretch by 2. Now the next thing I have to do is apply this K. Now that K is going to show up in the last graph. Now since my K is -5, and we have to remember that the K is going to be a shift, a vertical shift up or down. And since it's a -5, this is going to be a shift down by -5. So what I'm going to do is I'm going to move my asymptote and every single point that I have graphed in this graph and move it over here, but shift everything down by -5. Now I'm looking at my final answer graph, and it's blank. Now what I have here is I've redrawn my axes in my own handwriting here. And the first thing that I'm going to do is I'm going to move my axes, and then I'm going to move all the points with it. So since I have a K value of -5, that means that my K is going to move down 5. So watch what happens. I'm going to kind of just drag this down, and you're going to jump right to -5 and plot that. Now I'm going to undo that, and I want you to see what happens if I show you my entire graph. Now this is parent function plus vertical stretch, shrink, flip. In this case, it was a stretch. Now watch what happens. What I'm going to do in this program, I'm only going to drag down the horizontal asymptote, the floor. But watch what happens. As I draw the floor is connected to the rest of the graph. So as I drag down the floor to -5, you're going to see the rest of the graph go with it. And look at that. Now, notice something. Do you recall that before we had a height of 2? We still have a height of 2 from the floor. Remember that this was a height of 6. Now it's still a height of 6. 1, 2, 3, 4, 5, 6. And this was a height of like 2/3. Now we're going to need to name these points. This gets a tad bit tricky. When we name the points, we remember that it starts from the 0. So this point here is 0, -3. This point here is 1, 1. Now these points here, this program is going to give you decimals. I don't want you to give me decimals. I want you to give you fractions. And it's easier that way, I promise. Now remember, this was, let's go back up. This was a height of, when this was 0, this was a height of 2/3. Remember, it was 1/3 doubled 2/3. So I'm going to drag this down 5. When I drag it down 5, it's going to be -5, -5, and then up just 2/3. So a little shy of, let's see. Oh, too much. So 2/3 from that is -4 and a bit, -4 and 1/3. Main point here is the asymptote moved down to a -5, and your final answer graph still looks like a exponential growth function. And the height from the ground is important. And then you can name very clearly a few of these points. Again, you would name this -4 and 1/3. The horizontal asymptote moved down 5. There's no h value. If there were an h value, then your y-axis would also shift left and right. And then when you plot your new graph and your new axis, you will see your final answer like this. And then we're going to say that we're going to ask you to identify a few points. Let's say another direction. It might be 3, might be 5 important points there.